Okay, I think we're live. I do need a better mechanism for checking this, but I'm just going to. Perfect. Okay, looks like we are good. Okay, so things have changed a bit since yesterday, and I decided to not continue further on this book. I think it's a good book and a good introduction to mathematics. However, I don't think there'd be much experiences of um, enough experiences with me interacting with a complex topic and needing to work through it, and also like taking things and putting them into Anki. So I've decided to just kind of switch things up and instead began learning calculus, as you saw by the live or the title of this. And so for that, I really have, or I've wanted to not put any effort in beforehand for planning and things like that. I do have a calculus book that's been laying around in my room for a while now. But I won't use that entirely. I had this thought while I was at the gym today, while I was listening to a podcast. But books are great sources of information, and if I'm wanting to go through the material as quickly as possible, or to just go as efficiently as possible, interacting with the book will be part of that, but certainly won't be the entirety of it. I think initially I plan on just getting sort of a ChatGPT summary of what topics would be needed to say that you've learned calculus, right? And then also getting like a sort of summary of topics that would be the minimum needed to pass calculus tests. Okay. And then this will provide me with like sort of my the most important core things, right? The core competencies. And then from this point, so I'm going to drill down. I think I'm going to drill down primarily on those initially, ensuring that I learn each of them. And then I will sort of flesh out more ideas from, or look into more ideas in regards to this book. Though I think I will be doing it in the context of this book. I'm sure that I'll just be using ChatGPT, at least initially. That's the one I have. I purchased access to. But I'm sure that a ChatGPT was trained on this somewhat, or trained on summaries of this, such that it could spit out an overview of this book. Yeah. Okay. So I think we will just start from there. Yeah, so I wanted to kind of go through the very, very get-go of what it would look like for me. And then because I'm going to be going over I guess another part of reason why I wanting to avoid this for now. I have read a very short introduction books in the past, and they are good. They enable you to get a brief, introduction of a topic, which is nice. But because of that, they don't go much in depth, which is obviously the intent of the book, right? And so one thing that is very like indispensable with these is that you get the perspective of what the field looks like from a professional within the field, which is actually pretty hard to get. If I were just to be studying myself, it would take me years to be able to have an understanding of what mathematics looks like as a mathematician. And so I read a sociology, or a very short introduction to sociology recently, and that was something like I really like I was thinking through like, okay, like what was good about me reading this book, what was beneficial, could I have done this in a quicker way, and I realized that obviously I got some of big ideas within in sociology, and I think determine or the author being able to select who are the the fathers of sociology or something like that was helpful. But I think the biggest thing that I got from the book was understanding what sociology looked like to a sociologist, right? And so, and with cruising on a topic instead, I can focus on explicitly, or I can focus directly on that topic. Where the mathematics book, it just kind of goes where it takes me, and I think some part of like self-led learning is this sort of like general introductory topic book, though I'm looking for something like this. So without further ado, we will hop into this. Yeah, so I initially wanted to get an idea for what I'd like for the structured plan I'm going to use in order to, learn calculus. So let me switch to this view here. Oh, that's an unfortunate placement. Okay, that's better. Okay, so what I have here is, let's see, we're gonna open up onto ChatGPT. Is just a file open. This is Obsidian. It's a tool I like to use. And I have Anki here, which we will begin using once we sort of dive into this. And then I have ChatGPT. So we'll just start off with, let's see, I am going to be learning calculus. I am going to be teaching myself calculus. I have the 3rd edition of Calculus by Michael Spivak. So I would like to give you I would like you to give an overview of calculus in the context of this book that focuses on the minimum knowledge necessary to scrape by in a college course. Okay, so the minimum knowledge necessary to scrape by a college course with a C grade. After this, overview of the topic of calculus, again in the context. I would like you to focus on specifically those things that, okay, so I'd like you to focus specifically on those things that need to be known. Abilities need to be had. Okay. Okay, perfect. We will see how that goes. Okay, so when you're learning any particular topic, to know the topic means that you know all the discrete facts that need to be known in order to be or in order to know the topic, right? And you can do all the discrete behaviors. So if we just boil down learning calculus into if we boil down learning calculus into sort of learning a minimum number of things conceptually and learning a minimum number of things procedurally, then we really have like a pretty finite set of things that we need to learn such that we can know calculus, right? Okay, so looks like I think I might swap this one here and then we'll go. Okay, that's better. Okay, so looks like we'll need to know what limits in continuity are, derivatives in basic differentiation, integration in the fundamental theorem of calculus, problem solving and notation. Okay, and then more thorough one, limits in continuity, differentiation, integration. So series, sequences, and convergence, that was one that was not included. Proof techniques, not included. It looks like there are some broader topics. Okay. I also want to know what calculus is thought of from a individual who is a mathematician. View calculus. Okay. Okay, calculus is much more than a set of techniques for computing derivatives and integrals. It's a cornerstone of modern mathematics that bridges the intuitive world of computation with the rigorous foundations of analysis. A foundational pillar in mathematics. Historical, let's see. Okay. Mathematicians tend to view calculus from two interrelated perspectives, a computational toolset. In many applied contexts, such as engineering, physics, and economics, calculus is viewed... Actually, I'm going to start back up here. Historically developed by Newton and Leibniz to solve real-world problems in physics, calculus provides the language and tools to study change and accumulation. At its heart are concepts like limits, continuity, and integration, which allow us to rigorously analyze how quantities vary and aggregate over time. Over time, these ideas evolved from practical methods into a subject with deep theoretical underpinnings, leading to the development of real analysis and other advanced fields. Two complementary perspectives. Mathematicians tend to view calculus from two interrelated perspectives. Computational toolset. In many applied contexts, such as engineering, physics, and economics, calculus is valued for its powerful methods to solve problems involving rates of change via derivatives and accumulation via integrals. Here, the focus is on technique, mastering differentiation rules, integration methods, and being able to set up and solve practical problems. This working calculus is essential for modeling the physical world and solving quantitative problems. The gateway to rigorous analysis. From a theoretical viewpoint, calculus is the first glimpse into the world of mathematical rigor. Mathematicians study the precise definitions, like the epsilon delta formulation of limits, the formal proofs of the fundamental theorems, and the careful logical structure that supports the subject. Texts like Spivak's calculus transform the subject from a collection of procedures into a coherent and logically robust framework. This rigorous treatment is not just an academic exercise, it lays the groundwork for further study into fields such as real analysis, differential geometry, and functional analysis. The broader role of calculus. Interdisciplinary bridge. Calculus serves as the meeting point for algebra, geometry, and analysis. It gives a unified approach to understanding different mathematical ideas, how different mathematical ideas interact and reinforce each other. Inspiration for further developments. The ideas developed in calculus have spurred advances in other areas, such as the study of differential equations, optimization, and even more abstract branches of mathematics. Conceptual elegance. Mathematicians appreciate calculus for its ability to capture complex phenomena with surprisingly simple underlying ideas. The transition from finite sums to integrals and from average to instantaneous rates of change encapsulates a deep conceptual leap that is both elegant and profound. Okay. So two perspectives, a computational tool set, and a gateway to rigorous analysis. Interesting. Okay. Okay. And now I'm just going to add my first card. What is calculus? And I'm hoping for them to talk about both derivatives and integrals here. Okay, limits, derivatives, integrals, infinite series. Okay. Okay. And then I'm also, so this is an Anki card. Here I'm adding the title of the card, or the front of the card, which is typically in the form of a question, and the back of the card is the answer to that question. Anki cards are powerful because they, so these cards are for the use of reviewing, or I guess the use of understanding, over understanding and having like a deep knowledge base over, whatever topics you aren't interested in. And it accomplishes this through, actually I might just go ahead and teach some about this. Excalibur. Okay. What Anki does, so let's see. I'll just go a brief discussion. So we forget things over time. So like once you learn a particular thing, say over a period of time, you'll begin to forget that. That's a completely reasonable statement. Let's see. Okay. And so what one can do when you are forgetting something is to review that thing, right? So you begin to forget the thing, and you review the thing, and then you get back to a level of competency, and then you begin to review the thing again, and then you get back to a level of competency, and then you begin to forget the thing again, right? And how that works in practice is that you rapidly begin to forget something when you initially learn it, and then after you learn it again, the time it takes a little bit longer to forget this thing, and then a little bit longer to forget this thing. So what you're doing with spaced repetition is that you are fighting forgetting through remembering, right? And we review cards at specific times, or let's see. We review cards in a specific way, such that the cards, let's see. Yeah. So this idea here, okay, I'll just go over this first. This idea is spaced repetition, right? Or spaced retrieval. So after a period of time, we're retrieving our understanding, or attempting to retrieve our understanding of this particular thing, studying, and then we recall the thing or have the thing in our memory again. Okay, and so we continue to retrieve over time, and our memory grows over time, right? In these like spurts where we go up and then we forget, and then we forget. Anyway, so what Anki does is it is a spaced repetition flashcard program, and it allows people to build decks and build card sets, so that, or over like any material, right? And one profound thing about these cards is that like when you review a particular thing, it will, if you reviewed or if you remembered it super easily, it will push it out into the future. But if you remember it like not as well or don't remember at all, it'll bring the review date closer to the next time you see it. And just in line with like this concept here, where it's gonna take longer for us to forget. So it is the case that if we remember the card really well, it'll be pushed out far into the future, right? We'll say like 2 weeks. And then if at that time we review 2 weeks later, it will be pushed out even further into the future, like 4 weeks, right? So we're increasing the time between our reviews if we review or if we are able to recall something, right? Which I think is reasonable. And what that means is that the cards that you don't remember quite well, you see often, right? You're reviewing those things. But for those cards that you are able to recall like super easily, they get pushed out really far into the future. So this sort of emerges that you're focusing your time on those things that you aren't remembering well, or focusing more of your time on the things you aren't remembering well. And then for those things that you remember super well, they get pushed out really far in the future. Additionally, another powerful thing for Anki is that when we forget something, it's not revealed to us that we forget it. Like you don't forget a particular fact you learned in school and then remember the fact that you forgot the fact, right? And so what Anki does is it can reveal to you that you've forgotten something such that you can then study it, right? So that's actually a really powerful thing. So yeah, now we'll go back. So this is Anki. Ta-da. And this is the front of the card. This is the back of the card. This is an optional reverse. And so like when I am building a card, I want to have the idea of like what is calculus to be tied to the idea, this definition. But I also want to understand, I also want to be able to connect my definition for what calculus is to the idea, right? And so what I'll do here, could you provide an Anki? So it's like one of your cards will be the definition and you want the term, and then the other card will be the term and you're wanting the definition. And that varies slightly somewhat, but that's like the big idea. Because if I want to remember something, and remembering involves tying these two concepts together, or tying these two entities together, in this case a term and a definition, then I'd like to be able to both understand the definition and what the name is, the term, and the term and what the definition is. So you're connecting it both ways. And what this add reverse here does is that it will optionally add so if I didn't add here, I wouldn't add another card. But with me adding the reverse, it will add a new front, or a new card that has this as the front, and then this will be the flip side. At least that's my understanding. Okay. And then for these, typically you have like a front and a back and then a reverse and the back of the reverse. But when you have this one here, it will use this front card, right? And so I don't super care about, and I'll actually have to check this because I've used these recently, but I've added a lot of cards before I've used them. So I may have just loads of my cards that are entirely wrong. So that's, well, not loads, but like 100 or so. So yeah, so it will be this question and this will be the answer. So I do present the answer in a sort of like, Jeopardy way. What is calculus? But I find that like manually adding it isn't worth it because the question answers itself kind of thing. And so we will do that. Okay. So now that I'm here, I kind of want to build a plan for this. Let's see. How do we want to go about this? I'll just see. Could you now build a plan? Oh. And additionally, I think I want to go into things. So maybe I'll just learn the terms first, because I'd like to go into things having some idea of the terms before I just interact with the mathematics. Because I think I will be able to conceptually understand these terms pretty well, but like I've never taken calculus before. I took pre-calculus in high school, but like everything else is new to me. And so I'm actually probably going to have to backtrack on a lot of material. Or I guess I may have to backtrack on a lot of material. I'm not sure. So we'll go ahead. So it may seem odd that I'm sort of identifying things or terms that I'll need to know and to understand them like in a sort of atomized way instead of like viewing the whole. And yeah, that is the case. But I think this has helped me to be able to have context when I'm going through the rest of the material. So we'll say, because I'm unfamiliar with calculus, could you provide a list of terms of all the terms? Actually, I'm wanting to like have a list of terms that I can add here, such that I can sort of track. Yeah, I'll add them there, and I think we might even start building Anki cards. I do kind of want to maybe a bigger overview of calculus before I start adding cards, just so I'm not like adding cards into the abyss. Because I'd like to have some conceptual like economy for that. Or sorry, like a conceptual framework. Okay, let's see. Okay. So I think we'll just go to YouTube. Quick introduction to calculus. We'll see what this does. 4, easy calculus, introduction. Okay, so I think we'll start here. Actually, I think I like this one. Looks better. The OChem teacher. I think I've heard about this guy before, so we'll definitely do that. Okay. Okay, and I haven't decided quite yet. I typically listen to things faster, but for streaming, I think I'll just go for 2x. And if I need to slow it down, then we can do that. It helps you evaluate a function, enables you to understand what happens as as you reach a particular value. Okay. And I know I am doing all this out of order here, but it's also helpful to figure out what I know about calculus before going in. And I think perhaps I'll have like a more regimented approach for this. I just thought of this. There are there's like a very, very few things that I know about calculus. So I do know like that calculus is used to evaluate or figure out like the area under curves. And I do know that it has to do, like, enables you to look at functions, or rather, I don't know. I wouldn't say that I know. I've heard that it has to do with functions and determining what happened, or let's see, with functions where the values change, or the values are changing as the values that are being used are changing over time. I don't know if that's entirely correct. And I also know that, like, yes. So I know that it has something to do with this. And I also know that it has something to do with functions, where the functions are, like, or the function values are changing over time. And obviously it's the case that, or maybe, okay, so I'll just say, maybe we'll zoom in a bit. F of x. So I do remember this notation from, no, actually I don't even know if I want to use the notation. Anyway, so obviously it's the case. Okay, I'm actually not sure about what my thoughts are on, like, the nature of the functions. But I do know that, or I've heard that calculus is about understanding functions, or something about functions where the inputs are changing over time. Though it's also the case that, like, values also just change over time in functions, right? And like in like a normal slope function, like values are different here versus here versus here. So maybe it's the case that there's like some sort of actually, I have no clue. Yeah. So I'm not sure about what that thought is. So I do know something like this. And obviously this calculating, well, okay. I think that's actually all I know about calculus. I do know that it was Newton and Leibniz. And I did know that before I read the ChatGPT summary. And let's see, what else do I know about calculus? I do know that it's much better, or it's good about, like, modeling the physical world. Like, calculus is kind of an intro to, like, well, we can do things with math now besides determine how many apples we have left after we've bought some and sold some. And so, Okay. So limits help you evaluate a function as you approach a certain value. Derivatives, and then also it might seem silly that I like started at 2x and then I stopped it. However, I found that like I should have just continued at 1x, right? I found that like having if you're wanting to be efficient with learning the new material, being at the speed that is like enough for you to understand is good. And then if you need to stop, then stop. Because if you were to just stay at that 1x speed, obviously like there would have been some time that you like sort of lost. So so you just want to ensure that you're at a correct speed. And hopefully, I never thought about this, but I don't know if I have. Oh, okay. So I don't think I've been doing the audio here. Okay, we'll restart.
So there's 3 areas of calculus that you want to be familiar with. The first one is
Okay, and so I'm going to decrease the volume here just a little bit.
limits. Now, limits help you to evaluate a function. Let's say if we want to evaluate f when x is equal to 2, but for some reason the function is undefined or we just can't do it.
Okay, and this seems similar to the voice levels of my mic when I speak, so I think this is good.
In this video, I'm going to attempt to teach the fundamentals of calculus in a very short.
And we may not get through. Actually, we're about 10:51. So I think I'm actually going to end here tonight. I'll pretty much just pause here, and then we'll start tomorrow at the same point. I am wanting to. So one thing that is of interest for me when I'm doing this is to understand the process of learning more. And so I'm going to be like pretty explicit with like just writing things out. And so I may do some of that off screen in some of my reflections. And so we may have more stuff here tomorrow. But yeah, I think we sort of have like a bit of an idea for how things are going to look. And yeah. So I will see you guys tomorrow.